So we're going to briefly talk about this population project. So the first thing you're going to need to do is you're going to do this with your partner. So with whoever is in that desk beside you, your shoulder partner, you're going to do this project together. If you do not have a shoulder partner, you can go find somebody else, or you can just do it individually. And do not make a group of 3. This is just done with 2 people. You can do it individually if you prefer. It's going to be a little bit more work though, but you can do this with a partner. Alright, so you'll see that I gave you the population of the United States, population of Mexico, population of China, population of India. You see this huge chart with a ton of data on it. And you do not need most of this data. All you really need is the very first 2 columns. So all you really need is this right here. Alright, year and population. I don't know why I colored all over that. So you need the year column, the population column. The reason why I gave you all of it is I just copied and pasted over, and it was easier to not have to cut it all out. So all you really need, first 2 columns. So you can break this up however you would like. I would say give these 2 countries, this page, to one partner, give the second page to the other partner. You can break it up as you like, but anyway, break these first 2 pages up between you and your partner. And down here it says the U.S. population logistic model, y equals, and exponential model, y equals. So in the last lesson in 3.1, you should have learned how to use your calculator to make a logistic model and to make an exponential model. If you forgot, I'll try to pull my calculator up. You'd go to Stat, Edit, you'd go to your X's and L1, your Y's and L2. Now this is very important when you're using very large numbers. For this first one right here, where it says 2017, since your first year is 1955, I would let 2017 be the number 117. And then the population of 130 million, I would make 130 point, and then say 222815. Okay, and so by doing that, I keep my numbers smaller. My calculator is able to do this a little better. My calculator is able to make these predictions a little more accurately. Just remember when you get your final equation to convert your answers back. So when I see 100 and something as my answer for my y, I need to multiply whatever I get by 1 million. Same thing for years. I'm going to go years by ones here, but every year I'm really adding really 1900 to it, because I'm going to start at 1955 as being just the year 55. You can do it putting the whole numbers in there, it just will not work quite as well. Occasionally it gives you an error altogether. Sometimes it'll work. There you go. So, going back to my calculator, after I get my data in there, I go to Stat, go over to Calc, and for exponential, I use number 0, EXPREG. I plug in exponential and it gives me my exponential model. For my logistic, it's option B, is logistic. And so you'll do that for the US model, make your models, and then again for Mexico. Coming down here, you'll do it again for China and India. Okay, so do those first 2 pages first. Again, give one page to one partner, the other page to the other. After you finish those, then you're going to look on here. Well, this time they actually give you forecasts. Notice these are years that haven't happened yet, and these are the population that they forecast. All right, so they did the same process we did. They came up with a model, and they came up with their population model. So you're going to look at your models and think, well, which of these gives me the best match for the one they get. So for instance, for US, I'm going to look at the model I did and say, okay, which of those models, my exponential or my logistic, gives me closest to this? The easiest way to do this is to plug your exponential in y1, plug your logistic in y2, and then go to your table and then find these values on your table. And remember that this should be 120, this should be 125, 130. And if you use the table set, you can go to that. By that, I mean that if I go to second table, and I'm right here, I do not want to scroll down until I get to 130. I can do a shortcut. I can hit second and then window, and I can say table start. I want to start at 120. And now when I hit second, or and S also, I can say, well, I also, not only do I want to start at 120, I want to go up by 5s. So I'm going to say 5 right there. Now when I go to second table, I'm at 120 and it's going up by 5s. And so if you plug your exponential for United States in L1, and then plug your logistic for United States in L2, you will see your Y values for both of those models here, and then just compare them to these and see which one's closest. Neither of them are going to be exactly on. You're just figuring out which one of those is the closest. And so after you figure out which one's the closest for the United States, you circle either logistic or exponential. Same thing for Mexico, China, and India. Alright, so complete that with your partner. And again, you can break those up. Give 2 to one, 2 for the other. Just make sure you're looking at those together and you're agreeing which one's which, because sometimes it might be more difficult. It might start off in the lower years being closer to exponential or logistic, and as you get down here it might switch, so you need to kind of decide together which one you think is closest. And then you're going to get to the last page, and notice it says right here, answer these questions with your logistic model. So we're just using logistic models for these. So it says, what is the maximum population for each of those? And if you're paying attention on the logistic lesson for 3.1, you should just be able to look at your equation for logistic models and find out what the maximum population is. And of course, you don't have a maximum population for exponential. And then using those models, and really what you just wrote down, will India ever pass China in population? And if so, what year do you estimate it will pass? And you can actually graph those two models and use those to figure out if it does in fact pass. Will Mexico ever pass the U.S. in population? If so, which year? And again, graphing. Will the U.S. ever have a population of at least 500 million? And if so, when? So looking at the model, will it ever reach 500 million? And if it does, using the graph or the table, you can use the table in both of these as well, and find out when is that going to happen. And then what is your estimate for the population in 2100? So by you plugging that value into your equation, and remember to change it because this is the year 2100, then what kind of x value do you need to plug in, and see which value you get out for each one of those. How accurate do you think these models are? So give me some words. Alright, so you have to write a few sentences there explaining how accurate do you think they are and why you think they are. What events could cause populations to rise higher than your model's prediction? So think about that one. And then what events could cause the populations to be lower than your model's predictions? Okay, so think about what kind of factors could cause our populations to change to be different than what our predictions are. Alright, I hope you enjoy that and learn from that project, and I will see y'all on Tuesday to talk about how we did.